In this lesson, we're going to cover how to import points both into a 2D sketch and a 3D sketch, and also how to work with splines. The file that I have open is called importpoints.xls, and it can be found in your Chapter 7 exercise folder. Inside this Excel spreadsheet, I've already created a row that's going to designate the unit, in this case millimeters, and then I also have a heading for the XYZ data. And then underneath there are the different points that are back in. If you do not have a unit specified here, it will use the unit that is being defaulted inside of the Inventor part. So I'm just going to go ahead and close that Excel spreadsheet out. And let's start up a new part file. In this case, it's going to be based on the millimeter part file. And you'll see that I'm in the 2D sketch. From the 2D sketch panel, I'm going to slide on down and click Import Points. Again, from the Chapter 7, I'm just going to import that file. And you'll notice inside that spreadsheet there was a Z column, but in this case I'm in a 2D sketch, so it's popping up a dialog box alerting me to the fact that only the X and Y data will come in. Do I want to continue? I'm going to go ahead and click on Yes. And if I spin the viewpoint here, you'll see that the points all fall on that same plane. So let's start up another part file. In this case, I'm going to return out of the 2D sketch, and then I'm going to create a 3D sketch. Again, we're going to issue the same tool, import points, import the exact same spreadsheet. Now in this case, we didn't get the error, being that the 3D XYZ data has no problem coming into the 3D sketch. So now at this point, what we can do with that data, I'm simply just going to connect the dots using the spline tool. So it can be a very easy way to go back and get that data from an Excel spreadsheet into Inventor. I'm just going to close out of the part file with the 3D sketch. And let's go back to the 2D sketch. And we can do the exact same thing. Again, from the 2D sketch, I'm going to select on Spline. You may have Line as your current tool, so it may be under that drop-down list. But all I'm going to do here is just like I did in the last file. I'm just going to select the points. And then when I'm done grabbing those points, right-click Create. And if I spin the geometry around, you can see that it falls on the same plane. So what I'm going to do next is we're just going to start up a brand new part file. And what I'm going to do is I'm just going to draw in a spline. I'm going to start it off at the projected 0, 0 point. And as you can see, I can just go back and draw in segments. I am getting feedback at the bottom of the screen to help me designate where the points are. The spline does not need to be closed. So in this case, I'm done drawing. I'm going to right-click, click on Create. Now from these points, we can go back and we can work with them as though they were just regular lines, arcs, and circles that we're very familiar with drawing. So in this case, we could go back and place in general dimension between the points, horizontally, vertically. In this case, we'll just designate that point between there to 10. Horizontally, let's put that to 12. And you can see that the spline shape will change depending upon that geometry. Also, there's a constraint that we can apply that is referred to as smooth or a G2. So in this case, if we had another arc or a line out here, we could go back and define the point that that spline and that geometry is going to be connecting at is going to be forever continuous or smooth or a G2. So in this case, we don't have that, so we're not going to do that. But there are some other editing options available when editing a spline. If you move your cursor over that spline, you can right mouse click, and at this point we can go back. You can see right in this section right here, I can display the curvature. And as the lines go further around, telling you that you have a higher point of curvature there, again, we'll just move our cursor back over that spline, right click. In this case, we'll deselect the display curvature. Now, as I move my cursor back over one of those points, I can right click. And we have some other options here under the bow tie. I can bring up the handle. And if I zoom in tight, this handle, I can go back and I can drag that out. As you can see, the longer that the handle is, basically it's defining the flatness at that point. I can also apply a dimension to that. So the bigger the value here, so let's put it to 1. As you can see, it kind of straightens it out a little bit. So right click, done. Again, right click. I can go back and do curvature. So if I want, I can now designate, place in a dimension on the curvature. So in this case, it'll be a radial dimension if I type in 15. So really helping me define how that spline is going to look. I can also move my cursor back over that spline, and we have some different fit methods that we can go back. And basically these are just different algorithms that are going to interpret how should that spline be interpreted between the points that we placed. I can insert another point. So we'll insert a point right up here. Just right click, insert point. And now the point has been added. As you see, I can go back, I can drag that back out to that point if needed. I can also right click again. You can close that spline. In this case, bringing this to a nice closed profile. I can undo that. And lastly, we can go back and determine the spline tension. Let me slide this over so we can see it. So with the slider bar, as you see, the higher it goes, the flatter it's going to be between the points. Whereas I take it back to 0, it's furthest away from the points on how it's actually going to be blending from one point to the next.